What's up, everybody? Today we're going to try to go through two really important aspects of plant physiology. I want to focus in on transport specifically, but we're going to separate that out into water transport and sugar transport. Okay, so we're going to cover transport in trees. Let's get into it. So today we're going to talk about vascular tissue in plants. I need to describe a couple things to you just in terms of general anatomy, make sure we're on the same page here. But this stuff on the outside, this is called core cambrian. It's the bark, obviously. Okay, just inside here, so just inside on the very edge of this, this is the vascular cambrian. This is what's going to be creating new cells. So right here on this edge, on the outside of that, so just like right in between, that's where all your active phloem is going to be. Okay, and then on the inside of that, that's where your most recent xylem is going to be. So as the tree gets older, it grows out like that. So here you can see that we have these nice concentric growth rings on this piece of firewood here, but you guys can count how old this particular tree was. These are all annual rings that the tree experienced during different growth phases. You also can see here some of these years the plant grew a lot more than in other years. So the width between rings gives you a good idea about the climate and different growing scenarios during that time period. Okay, so in many ways trees tell us a lot about historical events, but this is when the tree was first growing, and then as the tree went taller, as we were explaining to you the other day, primary growth as it went taller needs to get wider to support that vertical growth up and down. Okay, and again, out here on the edge is phloem. Inside that, just inside of that, on the other side of the vascular cambrian, this is all xylem. Remember, phloem is where the plant transports its sugars. Xylem is where the plant transports its water. Okay, so this from here to here is all dead, pretty much. Okay, the two types of cells that I want you guys to feel comfortable with that comprise the xylem are going to be vessel elements and these things called tracheids, and they're responsible for the conductance of water. Typically water, in almost all cases, is going to go from the root system, from the bottom of the tree to the top. We're going to look at that a little more detail in just a second, whereas the phloem is typically going in the opposite direction. Okay, and there's only a very small portion when we look at the overall area of this tree trunk that's supporting the transport of sugars. It's on the outside here. So again, I mentioned this the other day, but if I cut the tree just the first inch or so all the way around the outside, I can damage that tree's ability to move sugar sap down the tree. And of course, like maple syrup, which you guys hopefully all enjoy, all we gotta do is tap into the tree, and when the tree is sending its sugars and seasonally moving its sugars, we can actually pull those sugars out of the tree and into a bucket and then concentrate that for our maple syrup, maple sugar candies, things like that. I hope that all makes sense. Right now I just want you guys to understand where the phloem is, where the xylem is. And again, xylem at functional maturity is all dead. Phloem at functional maturity is still alive. Phloem, the cells are called sieve tube elements. Okay, so we have vessel elements and tracheids for the xylem. Sieve tube elements are going to be what you're going to find in the phloem. All right, so I just showed you guys what it looks like in the trunk. Okay, I want to try to break this down into three distinct regions of a plant, and this is true of all plants. I know I mentioned trees earlier, but really all plants have to do this. Okay, they're taking and absorbing carbon dioxide from the air. They're using that carbon dioxide to produce sugars in the leaf. Okay, and then they're going to transport those sugars for storage in the plant tissue so they can use it at a later time. Okay, I know I've joked with you guys several times, but plants don't make sugars to get eaten. That's ridiculous. No organism on the planet is designed for that, to be made just to die. These plants are making sugars for their own consumption later, so they will go through cellular respiration and break down the sugars that they produce. I hope that's clear. So what we're looking at here is an immature hickory, it looks like. Okay, you can see the trunk right there, pretty narrow. Okay, nothing too extensive. So overall, we're going to start here with water. okay? Water is going to start in the ground. So the water is going to be absorbed, and the soil hopefully is going to have some ability to hold the water. We're going to talk about soil nutrition here in a video later today, okay? But in terms of what's happening under the ground here, we have an extensive root system. As much tissue as you see above ground, we should be able to visualize would also be in an extensive root network in the ground. And so what's happening from a water standpoint is the plant is absorbing large quantities of water and minerals from the ground, okay? Certain plants are going to have different water requirements. You'll see like things around here like a cottonwood would be pretty close to a river because of the amount of water they require, and everything has a different level of requirement, okay? But the water absorption for almost, I would say the vast majority by far, but there are a couple that can absorb water from the air, you know, some of your epiphytes. But you guys, these plants that we're looking at here, they're absorbing all of the water from the ground. That water is then going to be transported up the tree in that central region. So if we look at a cross section of a tree like this, right about where the inside of my finger would be, you know, that's where the transport is going to happen, in the inside of that circle there, okay? So where the hole would be, that's where the transport of water is going to happen up this particular tree, okay? So water is going to get transported up the tree. Okay, now what's happening here, see if we can't focus in a little bit here. You guys can see that we have a huge leaflet here, okay? And on the back side, if I flip this over, you guys can see all the veins and the intricate network. But in between the veins, I don't know how well I'm going to be able to zoom in on these things, but you guys, in here there are these little tiny holes that are called stomata collectively, or a stomate. And those stomata, what happens is those are like little tiny mouths. What they're going to do is they're going to manipulate ions to push water into and out of the guard cells, which are like the lips of the mouth, and that causes the mouth to either open or close, okay? So these stomates right now should all be open, and the reason they should be open is because it's a beautiful day out and they should actively be absorbing carbon dioxide from the air, okay? So while that is happening, while the carbon dioxide is being absorbed, the plant is also losing water through those little tiny holes. And that's a balance that all plants have to deal with, okay? So they're absorbing carbon dioxide, they're losing water through the stomata, okay? And again, in order for this plant to keep those stomata open, it's gonna need to not run out of water. So it needs to make sure that it's continually taking water up into its tissue. Otherwise, this plant then has to make a decision, a choice. Am I gonna close my stomates and stop sugar production because I have no more ingredients, no more carbon dioxide? Or am I going to leave them open and risk desiccation? Okay, and we've all seen plants that wilt. In order for the plant tissue to maintain its rigidity, most of that is all water pressure. Okay, and so what's happening here is there's a tremendous pull off of the leaf. So there's a lot of water that's being pulled off of the leaf into the air through the process that we just mentioned called transpiration. Okay, in the roots, if we look at that a little bit closer again, down in here, what we have is a situation where the plant actually stacks up sugars and ions down in its roots. And if you remember early on in biology, what that does is establish a concentration gradient, okay? So it's putting so much stuff in its root system that's actually pulling water into those roots, and it's pulling that water into the root. So that creates a root pressure. So that brings the water on some trees, you go up to about a foot and a half higher, okay? But what's happening there is so you have a pulling into the root system, and that's pushing the water up. And then over here, we have these leaves that, like I just mentioned, transpiration is pulling from this end. So we got root pressure pushing, we got the leaves pulling, and then in the middle we have a situation where inside the tree, as I just showed you, all those growth rings, they're full of these things, you know, vessel elements, tracheids, these single cells that are dead, but they're very small and they have huge surface area. So they create a tension. You guys remember when water sticks to other things? We call that adhesion. And water is also sticking to itself, which we call cohesion. So you have root pressure pushing the water up. You have this cohesion, adhesion, tension that exists in a continuous water column through these tiny little straw-like chambers that come all the way up to the leaf, and each one of these leaves is pulling off water. Okay, I'll try to show you guys. I'm going to put a bag around, I don't know about this tree, but I'll put a bag around some leaves and we'll show you the amount of water that comes off of the leaf. We'll do that a little bit later. Okay, so that's pretty much what I need you guys to understand about xylem. Again, that's all water transport that we just talked about.